Okay, this is video 10. I want to talk a little bit about two important data types in Python, tuples and dictionaries. Okay, so a tuple is just an ordered list of numbers or data or whatever kind. It can be any kind of data. And so you might say, well, okay, how do you write it? Well, technically speaking, it's the commas that tell the interpreter that it's a tuple, but people like to write parentheses around them. It makes it clearer visually and avoids some syntactical problems. So let's say the values are 4, 5, A, and that's good enough. Let's say 7 or 3, and there's no particular order. Okay, so if you ask for what type that is, it says it's a tuple. This is like in a 4 tuple, a 5 tuple, a 6 tuple, and so on. And math people pronounce that tuple. People sometimes argue about the pronunciation. Okay, so it's a sequence type. You can reference the elements by the square bracket notation, just like a list. But unlike a list, a tuple is immutable. Once you've created the tuple, you can't do anything else with it. I mean, you can't add to it or change the value of the entries or anything like that. So why does this exist? Well, as we'll see later, largely so that it can be immutable, a way of doing a list that's immutable. There is one neat feature I'll point out, which we've used, which is tuple unpacking, it's called. So let's say let's make a list. T is good, we had there. So let's call it V is, let's see, X, Y, Z, W. Of course, that's you didn't tell what X, Y, Z, and W are, but let's do X, Y, Z, W equals T. And then what do we have? So X is 4. Remember, T was there. Y is 5. Z is A. And finally, W is 3. Every mathematician knows the letter after Z is W. Okay. So we've used that on feature. We've said if you wanted to exchange the values of two variables, you could do it by, let's say, A equals 3 and B equals 100. Then you can, suppose we want to switch them around. Well, you can say, let's say AB equals BA. So now B is 3 and A is 100. That's tuple unpacking. As I say, it's the comma really that determines it's a tuple. So it's just like the previous example. This is a tuple with two elements, and this is the list of variables. So you could write it, of course, as A, B. Let's write it again. It's going to switch them back. Equals BA. Okay. So now A is 3 and B is 100. Okay, so you just didn't put in, it wasn't necessary in that simple statement to put in parentheses. Okay, there's a couple of notational things to worry about. Namely, if you can have an empty tuple, and that's pretty simple. Just make it an empty parenthesis, and then you get a tuple, and then the length of it is 0. Okay, that's easy. But what about a tuple with one element? So if you do t equals 7, well, the ordinary rules of arithmetic say evaluate what's inside the parentheses. That's 7, and that's the value. So that's just 7. T is an integer, and its value is 7. So that doesn't do me any good. So what you have to do is put in a comma, even though it's not separating it from anything like that, and then you get a tuple, and it's 7. T of 0 is 7. Okay, so that's a tuple, and there's some more we'll say about it later, but that's pretty good now. Okay, the other important data type that we haven't discussed is a dictionary. This is sometimes called a mapping mathematically, or a hash table to computer people who are worried about how it's implemented. But basically the idea is you have a bunch of things that you can look up by key. So for each item there's a key you can use to identify it, and you want to look something up on the basis of that key. So there's something in the domain, and you get something in the range. And it's a hash table, which means that the amount of time it takes to look up an element is fast, and doesn't really matter where it is in the list or how, what methods you use to, how many elements there are and so on. So it's a faster way of doing key value lookup. You could, of course, put everything in a list and then try and use, you could fake it in a list, but it wouldn't be as efficient. Okay, so let me do an example here. So if you want to construct a dictionary, say D, you construct the key value pairs like this, so that something enclosed by braces is the dictionary, and then let's say the key is A, and the value is 5, and the key is Z, and the value is 7, and the key is W, and the value is 100. So you see that the value is, the key and the value are separated by a colon there. So those are key value pairs. So we have that dictionary. You can print it, or display it rather. Okay, so how can you do it? Well, the basic idea is if you could do T of D of A, you get 5. If you do D of W, has to be a character, W, you get 100, and so on. So you can give it the key in square brackets, and it returns the corresponding value. Okay, and what happens, how do you create a new value in that dictionary? Well, the same way, D of H is equal to 35, 34. And of course, I could do D of A is 200 to change the value of A. Okay, so everything's good. Of course, there's the question of, do you know what the keys are? If you try and look up a value for a key, D of M, let's say, then you get an error message, key error. And if you're not doing something about that, your program will crash. Okay, so that's not terribly convenient, but we'll see how to deal with it in a bit if you don't want that to happen. This would be more or less thinking of the case where you thought you knew what the keys were, but you were wrong, and so it was an error. You don't want a program to be running if an error occurs. Okay, so let me get some data that's a little more intuitive, dict data here. So here I've got a name and a number, and the number is I'm thinking it's a dollar figure. This is like totals for lunch this month or something, or whatever they've spent. We have to bill them. And that's not, I should add that you should never use a floating point number to represent a currency value, a value in dollars or any other currency. So there's appropriate Python modules. Don't do this, and the reason is round off error doesn't necessarily do the right thing. Okay, so we can look up those names and so on. So that's good. And there is a value, an ordering to dictionary. If I type amounts, I have to have a capital A, A-M-O-U-N-T-S. Oh, I have to run this file, I'm sorry. A-M-O-U-N-T-S. That was listed in the same order as I typed it up there. So there is an order in the key value pairs in a dictionary, which is the order in which they are inserted. So Jane is last over here in the display because it was last when I created the dictionary. Okay, so that will make a difference at some point. Okay, so suppose we have another dictionary, and we want to today's charges, and we want to update it. So let's say today is, well, let's see, Alice spent $10.32. Got it. Okay, Alice spent $10.32. Sam spent have to make it a string. Sam spent $21, must have had a guest. And let's do one more name, Jane equals, Jane is 15 and 75. Okay. I'm sorry, that's a bad habit from different programming language. Okay, so there you are. And the problem is we want to combine that with the previous amounts dictionary. Well, the first question is, what are the amounts what are the keys in the first dictionary? So if we do amounts dot, let's see, keys, it gives you this thing, which is Alice, Bob, Zeke, Sam, and Jane. It's got it listed as a Dick view object, a Dick keys object, which will be maybe a problem. We'll see. So I don't know, can we iterate over that? Let's say for key, let's call for K in amounts dot keys, do print K. Yeah, we can iterate over it. There's no problem. Okay, so in our today file, of course, the keys are not all there. They're not, all of the possible people are not there. And so we want to try to update the amount for those people, but not for other people. Well, that's pretty easy, it seems. Let's do for K in today dot keys. Then let's do amounts K. Well, equal amounts K plus 1 plus the today's value, but we can abbreviate that, plus equals amounts today with K. Okay, and then let's run that loop, and let's see what happened to amounts. Well, I don't want to do that. Okay, so it updated Alice, it updated Sam, and it updated Jane. Okay, and it didn't do anything to the rest of them. Okay, so that's what we wanted. Okay, what if somebody new shows up and today and starts a bill? So the today thing would contain a key that isn't previously there. Let's see, where's today? I need to find today. Okay, so suppose that somebody else shows up. Let's say Bill, no pun intended. And he just showed up today, bought $10 worth of stuff. Okay, well, if we run through the loop we had before, that's not going to work, right? Key error, Bill. Okay. Well, fortunately, there is there's a way to do it. There's a list method called get, and will returns the value. So let's do this. Let's do let's see what happens when I do it with Bill. So let's say amounts dot get Bill And, well, it didn't give me an error. What it did was return none. Okay, amounts.get bill. And let's see what it says. None, right. Okay, and you can detect that to see if Bill was there previously and add it if he wasn't. So you could say, okay, well, we would want to add him with the amount that he has today. So let's say 4K in keys, 4K in today.keys. If let's say, it will make it clear if I say amount dot get K equals none. That means that this hasn't been there before. Then what do I want to do? Well, then I want to say amounts K equals just the amount for today. And then end. What if amounts, oh, I see. Okay. Let's bring that back. So what I want to say is, well, this was a single equal sign instead of a double equal sign, right? I told you that was going to give you trouble. You have to watch that. And so let's see what happens. Okay, so now let's look at amounts. Okay, so Bill turned up with his $10 without doing anything fancy. And there's another method which is kind of interesting called set default. And I think I'm going to discuss that and continue with discussing dictionaries in the next video. I don't want to burn you out too much. You have a fairly good assignment to look at. So let me stop there for today.